Hey students, this is lesson 532. In this we're going to look at another patterns. We call these the difference of squares, and these first 6 problems here are examples of expressions that we consider difference of squares. We're going to look for shortcuts to do this, so let's see if we can find some patterns here. First of all, I'd like you to notice what all 6 of these have in common. And if you look closely at the expressions, you'll notice that the first number is the same. The last number are opposites, and they're multiplied. So, and they're all of that form. So in general, we can write this as this form, a plus b, and then exactly the same 2 numbers, just subtract it. And what we're going to try and do is generalize on that, try and figure out what kind of a pattern there is here. So I'm going to use the FOIL method just to multiply the first couple and then see if I don't notice anything going on here. So the first one, x times x is x squared. Then we're going to do the outside 2 give us negative 10x. The inside 2 give us plus 10x. And the last 2 give us 10 times negative 10 is negative 100. And simplifying that, we get x squared. Negative 10x plus 10x gives us 0x. So it's just x squared minus 100. This second one here, we get the first 2 terms give us x squared. The outside 2 terms give us negative 1s. The inside give us 1s. When we add those together, we get negative 1s plus 1s. And then the last 2 terms gives us negative 1. And again, we have negative 1s plus 1s. That's 0s, so it equals s squared minus 1. Let's do one more and just see what happens. 2t times 2t is 4t squared. The outside 2t times negative 5 is negative 10t. The inside 2 is 5 times 2t, which is 10t. And the last 2, 5 times negative 5 is negative 25. And again, we get 0 when we add those 2 together, so we get 4t squared minus 25. So this is a special case where we multiply 2 binomials, and we end up with a binomial because we end up with 2 terms that are opposite. So let's just kind of guess on this one what the answer is going to be. Since it's set up the same way, I'm thinking the first term is going to be k squared. And the middle term is not going to be there. It's not going to be a trinomial because you're going to have 1 positive and 1 negative. And the last term is going to be minus 9. So in general here, a squared, the quantity a plus b times the quantity a minus b is going to equal a squared. First term squared minus the last term squared. A squared minus b squared. Go ahead and do D and F. You can pause here and just see if you get those right. I'll put the answers here in a second. All right, hope you did those okay. We're going to learn how to do one more thing now. There's actually some mental math we can do by using this process. We're going to go down to this little cartoon here. And notice that this person here wants to calculate 46 times 54. And this girl has a trick here. Instead of doing 46 times 54, she's going to do 50 minus 4 times 50 plus 4. That's the same as 46 times 54. And when she did it like that, it's actually of this form, a minus b times quantity a plus b. And that is equal to a squared minus b squared. A squared, 50 squared is 2500. B squared, which is 4 squared, is 16. And so you can subtract those. All right, I'm going to give you one more example like that. Let's put it over here. Let's say we're trying to multiply like 42 times 38. Well, think of 42 as 40 plus 2. And 38 as 40 minus 2. And the reason that we're doing that is because now it's this form, a plus b and a minus b. And we know that that's equal to a squared minus b squared. My A is 40, so I'm going to do 40 squared. My B is 2, so I'm going to do minus 2 squared. Well, 40 squared, I can do that in my head. I just do the 4 squared, which is 16, and there's going to be 2 zeros on there. And then 2 squared is 4, and I can do this in my head. 1600 minus 4 is 1596. So, and you could actually, once you do this a few times, you could be like a human calculator and do stuff like that in your head. All right, so let's go ahead and do this one last problem here together. We'll set it up and then we can practice some more of these here. This is number 8. It's on the top of your page 8. So 99 times 101. Now that would be considered kind of hard to do without a calculator unless you notice that this number is 1 less than 100 and this number is 1 more than 100. So we can write it as 99 is 1 less than 100 and 101 is 1 more than 100. Now it's the form A minus B and A plus B, and my A is 100, so that's equal to A squared minus B squared, which is 100 squared, minus, and my B is 1, so 1 squared. Well, 100 squared, we can do that in our head. Let's just do 1 squared and then tack on 4 zeros. So we get 10,000. And 1 squared is just 1, so this equals 9,999. Go ahead and try a couple in here. See if you can learn that trick. And other than that, we'll talk about these special products a little bit more in class and do some more practice.